In the 1970s and 80s, the Soviet Union put 5 landers on the surface of Venus, and they each survived for over 30 minutes, and no one has ever tried it since. From time to time, someone will post to Reddit pictures from the Venera missions, and everyone goes, nice. And yeah, it's pretty cool that these pictures exist, but have you ever wondered what it took to build a machine capable of taking those pictures? Like, how did they actually do it? In this video, I want to look at the Venera space series and the engineering behind this stunning achievement. Sit back and enjoy. This is going to be a long one. But first, yes, let us talk a bit about the Patreon. If you want to help support the channel, you might want to take a look at the Early Access tier. Early Access members get to see a large backlog of videos queued up and waiting to be released to the public. Right now, there are over 20 such videos in Early Access. So head on over to the Patreon page and take a look. I deeply appreciate anything you'd be able to sign up for. Thanks, and on with the show. Let us first talk about Venus. I cannot imagine a harder place to land on anywhere in the solar system. Okay, I guess maybe the sun. But Venus comes in second. Venus has been called Earth's evil twin, the planet that started off similar to the Earth but eventually went oh so wrong. The two planets are close together and are similar in size, but the Venusian atmosphere is as different as it can get from the Earth's. This is due to a runaway greenhouse effect that has gone on for, who knows how long. The Venusian surface gets hotter than Mercury's, 864 degrees Fahrenheit or 462 Celsius. The surface pressure is equivalent to being over 0.5 miles or 1 kilometer underwater. That thick atmosphere presents special challenges. Its clouds are made up of sulfuric acid, used in lead-acid batteries and as an industrial cleaner. And you have to survive atmospheric entry, where friction can heat you up to 11,000 degrees Celsius. The Americans put a dude on the moon, but they never tried to put a legit lander on Venus. The Soviets would eventually do it 5 times. But I'm getting ahead of myself. Let us wind the clock all the way back to 1967. As the year was coming to a close, the Soviets found themselves at a crossroads. 11 launches to Venus, 11 failures. That was the scorecard going on to Venera 4. The mission of the Venera project, Venera is Russian for Venus, was to land a probe on the Venusian surface. With the space race in full swing, the Soviets wanted to outdo the Americans by piercing the Venusian veil. The American capitalists were sending a flyby probe to Venus that was scheduled to arrive in late 1967. So let's show them up first. For the Soviets, it was now or never. After Venera 3 failed to reach the ground, the whole Venera mission was transferred over to the aerospace company Lavochkin. Venera 4's launch date was set for the autumn 1967 launch window. Venera 4 was a hefty thing. It stood 11 feet, or 3.5 meters tall. Its bottom lander was essentially a bunch of instruments and a battery wrapped up in a pressure shell with a parachute. Venera 4 reached Venus in October 1967 and successfully launched its lander. The mother craft released the probe over the planet and it entered the atmosphere. Temperatures hit 11,000 degrees Celsius and entry forces reached 450 Gs. The onboard instruments began analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees Fahrenheit or 39 degrees Celsius. Atmospheric pressure was about the same as that on Earth. But both measures began rising, and they kept rising, quickly. 10 atmospheres, then 20, it just kept going up, far higher than anything engineers anticipated. 93 minutes into the mission, with the probe still 27 kilometers above the Venusian surface, Venera 4 cracked open, likely near its top, and was crushed. The measurements at crush point showed 22 atmospheres and 530 degrees Fahrenheit, or 277 degrees Celsius. By now, the American probe Mariner 5 had also reached Venus. It flew past the planet and sent back data on the planet's atmosphere and composition. The Soviets and Americans compared their probe's data and came to the conclusion that Venus was a hotter, drier, far more hostile planet than anyone had ever anticipated. As a great American once said, "We're going to need a bigger boat." This realization required intense engineering, but with construction for Venera 5 and 6 already finalized and the 1969 launch window coming up fast, there would be no time to make major changes. Engineers did what they could to strengthen the landing probe and left the radical redesign to the next launch. 5 and 6 were sent on a mission they were not fully prepared for, and the results were similar. Venera 5 transmitted data for 53 minutes before succumbing to pressures of 27 atmospheres and temperatures of 600 degrees Fahrenheit or 320 degrees Celsius. Venera 6 lasted for 51 minutes, but it had gotten slightly further, descending 37.8 kilometers into the atmosphere before also getting crushed. You know what? I'm sensing a pattern here. With the 1970 launch window, the program directors were determined to make it to the Venusian surface, whatever it takes. And now they knew what it would take. 840 degrees Fahrenheit or 450 degrees Celsius, 100 atmospheres, burning corrosive acid. Let's go. Venera engineers consulted submarine designers for tips on how to survive deep pressures. They sourced new materials to build it, and they got a hotter, stronger test chamber to test it. Engineers wanted to maximize the amount of time spent on the surface, so they modified the parachute to make the lander fall faster. When temperatures hit a threshold of 390 degrees Fahrenheit / 200 degrees Celsius, a restricting cord would melt, and the thing would fully open up to assure a soft landing. A nifty mechanism. The lander was built in the shape of an egg. Made of titanium, its surface was smooth, with as few ports, welds, or substructures as possible. The inside was lined with shock absorber and an unknown insulation layer. Like with its predecessors, the chamber would pre-chill to freezing temperatures before entry. After a 4-month journey, Venera 7 reached the planet in December 1970. It separated from the mothership and descended into the atmosphere, transmitting data for 35 minutes as it fell. The parachute at first worked as intended. Things seemed smooth. But 6 minutes into stage 2, the chute melted, or tore, and the probe dropped like a rock. Venera 7 then unexpectedly hit the ground at 35 miles an hour, or 60 kilometers an hour, at 4:42 a.m. Venus Solar Time. It hit the Venusian ground, determined to be harder than sand but softer than pumice, after free-falling and bounced. The signal then abruptly seemed to have cut out a second after landing. Soviet engineers sadly thought the probe was crushed to bits. But a few months later, radio astronomers reviewing the radio data rediscovered the signal, extremely weak and lost amidst the noise. Incredible luck. As it turned out, Venera's 7 bounce had misaligned the antenna and caused it to come to rest on its side, weakening the signal to 1 or 3% strength. The probe sat there transmitting data for 23 minutes in temperatures hot enough to melt zinc or lead until its shell cracked and it too melted. The data sent back by Venera 7 and Venera 8, a similar design launched 2 years later in 1972, helped pave the way for a new generation of Venusian probes. It would not be until 1975 that the Soviets launched their new series of Venera probes, 5 years after Venera 7. By then, Soviet engineers now knew what to expect and designed the two to do more than ever before. And that includes sending back black and white photographs. In fact, that was the probe's primary goal: send back the first ever photographic panorama of the Venusian surface. New rockets developed for propulsion to the Moon and Mars allowed for bigger probes than ever before. Venera 9 and 10 were 5 times heavier than their predecessors, weighing 5 tons or 5,000 kilograms in total at launch. Venera 9 and 10 had an orbiter and lander component. The entry capsule, the equipment designed to bring the lander to the surface, was a spherical capsule covered in an asbestos composite. It would enter the atmosphere, take on the heat, and split in half like a plastic Easter egg, ejecting the lander forward unto its destination. The lander was magnificently designed. The 6.5-foot or 2-meter tall lander was essentially a hermetically sealed titanium sphere, 2.6 feet or 80 centimeters wide with some peripherals attached. That sphere would hold the instruments and was bolted together with gold wire seals. Inside, shelves made of beryllium and electric fans would evenly disperse the heat to prevent instrument failure. The sphere's inside would be lined with a type of polyurethane foam now forgotten. They then wrapped the whole thing in 5 inches or 12 centimeters of a honeycomb composite insulation and another layer of titanium. On the bottom of the lander, they stuck a shock-absorbing ring. At the top, a titanium disc that kind of looks like a hat. That funky hat would serve as an aero brake that replaced the 2-stage parachute design that so troubled Venera 7. The way it works, the parachute entirely detached at 30 miles or 50 kilometers above the surface, and the aero brake does the rest. To see if it worked, Soviet engineers threw it out of an airplane 87 miles or 140 kilometers above the ground. 2 cameras were placed in the middle of the lander so that they could see both the surface and out into the horizon as far as possible. Equipped with goldfish bowl lenses, they were protected with a special pressure window made of pure quartz. The lander sent its image data, 512 by 128 pixels large, at a rate of 1 line every 3.5 seconds. Scientists estimated with all of this the entry probe would probably last an hour on the surface, just 1 hour, but it would take at least half an hour to send the full panorama, so I guess it was fine. Late October 1975, Venera 9 and 10 arrived and landed as planned. Their parachutes cut at 50 kilometers as planned, and both landers hit the ground at around 15 miles or 25 kilometers per hour. Venera 9 landed first, touching down on a slight slope, maybe a hill or the side of a volcanic crater, and kicking up a bit of dust at landing. One of the 2 cameras succeeded in photographing and transmitting their data. Scientists waited. Slowly the data trickled in, revealing our first ever image of the Venusian surface. What they saw were sharp rocks, soil, and a distant horizon. It might have looked like a spot back home, but it wasn't. These images traveled to us from a whole different world. The sun was shining bright on Venus that day, although obscured by the clouds, and there was a gentle breeze blowing. A pleasant morning. Well, except for the crushing pressures, nearly waterless atmosphere, corrosive acid, and 800-degree temperatures. Venera 10 landed similarly a few days later, but on much more boring terrain. A rolling plain with hardened pieces of magma. These rocks are much older than those Venera 9 saw. The acidic atmosphere has had time to chemically scorch them. Both probes transmitted for 50 to 60 minutes until their orbiters went out of range. At that point, the temperatures inside the probes measured about 140 degrees Fahrenheit or 60 degrees Celsius. They could have probably kept going. When they actually died, we don't know. The orbiters themselves later burned up in the atmosphere once they completed their mission. Venera 9 and 10 were stunning successes and represented a triumphant public relations event for the Soviet Union. They quickly sought a sequel. Venera 11 and 12 would go on to do some interesting science, but because a mysterious electric anomaly had disabled their cameras, the trips had largely been forgotten. It was a bit of a disappointing follow-up to the 9 and 10, but Soviet scientists were gearing up for the grand finale. Kind of like the iPhone 11 as compared to the iPhone 10, the Venera 13 and 14 retained the core principles from the 9 and 10, but refined the edges and corners. Engineers improved the cameras, the scientific instruments, and added new heat-resistant technologies. They were even able to rate it to last at least 30 minutes down there, guaranteed or your money back. And cool, color images can now be taken. The amazing thing was that many of these sensors and instruments could now be mounted outside the spherical pressure chamber. Made of platinum and covered in acid-resistant enamel, their placement is a testament to their engineers' understanding of and experience with the crushing Venusian environment. Venera 13 arrived first, landing as planned. The lens cap popped off as expected and took 2 photos. A first contingency photo of black and white, and then another in color. The photos showed a surface of pebbled, loose soil amidst outcroppings of bedrock, looking similar to the bottom of the ocean. In the distance, rolling plateaus and an orange sky. The Venusian atmosphere absorbs blue light, so most things will look orange or yellowish. Venera 14's images showed a more weathered plain, with fine-grained rock and far less loose soil. Something like a baked cake. The rock appears younger, but nobody knows for sure because Venera 14's drill famously drilled exactly on where the lens cap had landed. The two probes held microphones and sent back what they had heard. Amazingly enough, it never really occurred to the Soviets at the time to release the audio they picked up. You can probably find it on Reddit somewhere, but after you hear the lens cap blowing off and the drill drilling, Venus sounds like a gently blowing wind with faint hints of distant rumblings, presumed to be Venus quakes. An amazing Soviet achievement, but they would be the last landers to touch the Venusian surface. Venera 15 and 16 swapped out the lander component with radar, thereafter mapping the Venusian topography from orbit. The last Venera landers were built in the 1980s. Space programs since then have shifted to the Moon and Mars. I suppose there is a justified reason for this. No human is ever going to set foot on Venus. Well, alive anyway. But it is possible to send another lander back to the Venusian surface. Engineers know what to expect and that it can be done. The problem is, of course, economics and cost benefit. There is something weird about investing so much time and resources into a thing that survives less than a day. And by weird, I mean insane. Most of the Venus exploration proposals have been things like balloons and other high-altitude floating explorations. To make the economics for a lander work, you have to send something that can get there, move around, and last for weeks on end. The cooling technologies capable of doing that are, to put it lightly, a few years away. Much of the secret work done during the Soviet era for the Venera series is now lost, but there are some interesting developments in extreme environment technologies today that might make a return trip possible. Perhaps we can go over that in a future video if this one does well. Let's say 700 likes? Regardless, the Venera series was an amazing engineering achievement, and in my opinion, represented the country's pinnacle of space exploration. I loved researching every bit of this. Alright then, thanks everyone, that's it for tonight. If you want more content, you can like and subscribe to the channel. I would like it if you did. Remember to hit up the email newsletter and sign up. And if you want to send me an email, you can drop me a line at john@asianometry.com. I love getting letters from viewers. Until next time, I'll see you guys later.